Okay, let's go for some M9 Remembers. What are this ridiculousness? Methods are things we do. Remembers are things we need to remember while we're doing them. So I mentioned in methods I was going to further explain numbers. So all numbers are real. So that's why they're all in this gigantic rectangle. They're all real. And a whole bunch of examples at the top under real. Now, real numbers, sure. So there are also what's called non-real numbers, which we work on those later in grade 12 or calculus. So then real numbers are divided into irrational numbers, numbers whose decimals do not end and cannot be expressed as a fraction. Then we have rational numbers off to the right, decimals who end or repeat and can be expressed as a fraction. So in the rational numbers section off to the right, we have integers, which are the numbers on the number line, whole numbers starting at 0 going to the right, and natural numbers, numbers like 1, 2, 3. The Egyptians started with numbers like 1, 2, 3. 0 was introduced a long time later. And then in this funny blue square, it shouldn't actually be here. I'm just doing it to save space. And we just have letters for what they usually call the types of numbers. So irrational numbers, the numbers on the right, the numbers that can't be expressed as a fraction, like e and pi and 5.49 ... not repeating, root 2, etc. Okay, down below, exponents, exponents, and a bunch of stuff. So, remembering, never multiply the base by the exponent. Remember, you have to have the same base to use the laws, etc. Remember that, well, there's one more rule. I'm not even going to explain you that one. If you can figure that one out and use it, do it, but it's dangerous. Remember, there's no rules for adding and subtracting exponent laws. You just figure out the parts and then put them together. Okay, off to the right is everything on the negative coefficients broken down. So let's start with 2 cubed. Well, positive, obviously. Let's start with 2 to the 4. Positive, obviously. Let's look down below. Negative numbers to odd exponents stay negative. And if you do the case below that and put a negative in front of that, it becomes positive, obviously. Off to the right, taking that example, putting a negative 2 and keeping it, we have an even exponent, so it becomes positive. If we put a negative in front of that, it becomes negative. So we've already talked about how this, now this. Well, these two examples, well, the one on the left, well, negative numbers, well, both of them, negative numbers without brackets stay negative. That negative is so far off to the left. And then we have a whole bunch of cases of unnecessary brackets where the brackets just don't matter. Okay, back down to the left. Remember polynomials. Remember to circle or box or cloud your like terms. Possibly rearrange them. A little bit on triangles off to the right, like where the angles are and like opposite angles and how to label triangles. Inequality is all at the bottom. Remember, greater than, less than, etc. Divide by a negative, change the direction of the sign. Greater than, equal to, close dots, not equal to, open dot. Again, divide by a negative, change the direction of the sign. Greater than, equal to, and less than, equal to, close dots, and greater than and less than, open dots. Again, make your own remembers. Study for the test. Write down all your remembers. Don't write them down at the end. While your teachers are teaching you, write them in your notes and then consolidate them all on one page. Use them to study for tests.